How do we first make sense of the world around us? It all starts with these really simple, fundamental questions. The kind of questions we've all asked since we were kids, just pointing at things and wondering. So let's dive into that.
You look at something, right? Like a table, and your brain, it just immediately wants to figure it out. How far does it go? Could I reach all the way across? It's this totally natural, built-in curiosity about space and dimension.
Or maybe you pick something up, a cool looking stone you found, and you wonder about it. Is it heavy? Is it light? You're trying to understand its weight, its substance. And believe it or not, these super simple questions, well, they're our very first steps into the world of math.
Okay, so how do we usually answer these questions? The typical way is to just give us a ruler or a formula, some abstract numbers on a page, but there's another way, the Montessori approach, and it starts not with a formula, but with our hands, with the direct physical feeling of pouring something, balancing it, and comparing it to something else.
So, you might be asking, why start this way? Why put all this emphasis on feeling over formulas? Well, it's all about building a foundation that actually makes sense, one that connects those abstract numbers to the real, tangible world we live in. Look, the goal here isn't just to teach a kid how to use a ruler. It's about letting them discover relationships for themselves. This is longer than that, or this is heavier than that, way before we ever introduce a single unit like an inch or a gram. This makes measurement something meaningful, not just some boring mechanical exercise. So how do you actually teach something so intuitive and, well, hands-on? Definitely not with worksheets. You do it with a specific set of beautifully designed materials. And you got to think of these less like, I don't know, boring school equipment, and more like tools for pure discovery. Okay, take a look at these rods, for example. Just by lining them up, a child can literally see and feel the idea of length getting bigger and smaller. There are no numbers on them, nothing to memorize. It's just a pure visual comparison. It's a completely intuitive way to get the whole longer and shorter thing. And it's the same idea with balance scales. At first, it's not about finding the exact weight in grams. It's all about the experience of seeing one side dip lower than the other. It's a physical lesson in heavier and lighter that a kid can literally feel happen right in their own hands. And let's be honest, when it comes to volume, what is more satisfying than just pouring stuff from one container to another? With these cylinders and beakers, kids get to learn about full and empty, and they see for themselves how the same amount of water can look totally different depending on the shape of the container. Now, this is absolutely the key point here. These tools aren't just stuck in a math corner somewhere. They're woven into everyday life. Measurement happens when you're pouring yourself some juice, weighing fruit for a snack, or helping measure flour to bake a cake. It just becomes a totally natural part of living. So all this hands-on stuff, it's not random. It creates a really specific, really logical learning journey. It's a progression that takes you from what your body understands to what your mind can finally calculate. Let's walk through what that journey actually looks like. The whole journey starts with step 1, simple, direct comparison. Is this rod longer or shorter than that one? Then you move to step 2, which is matching things, using the materials to find things that are the same. It's only after that solid physical understanding is built that we get to step 3, introducing the language, the actual words like longer or heavier. And notice this, standard units like centimeters or grams, they don't even show up until step 4. And then finally, in step 5, they get to apply all that knowledge everywhere, from cooking to gardening to building. And this quote just perfectly captures the magic of it all. This child, she isn't solving a word problem from a textbook. She is having a moment of pure, unadulterated discovery. And that giggle, that's not because she got the right answer on a test. It's the genuine joy of seeing a principle of the universe unfold right there in front of her. Measurement becomes a fun exploration. So what's the big picture here? What's the deeper impact? Why does this hands-on approach matter so much? Because really, it's not just about learning how to measure things. It's about building a fundamentally different kind of thinker. It really boils down to these core principles. By starting with something concrete and moving to the abstract, you're building real confidence and intuition. By embedding learning in real life, you're sparking curiosity. This isn't just about teaching math. It's about cultivating creative problem solvers who want to understand their world, not just memorize facts about it. And that's really the biggest takeaway here. Measurement, when you teach it this way, isn't just another subject in school. It becomes this vital bridge that connects the abstract world of numbers and formulas to the physical world we all actually live in and touch every single day.
And that leaves us with a pretty powerful question to chew on, doesn't it? What if we all learned that math wasn't a test to be passed, but a tool for exploration? What if it was never about the pressure of finding the one right answer, but about the absolute joy of discovering the world?